Hi guys, welcome back to AI with MJ. I have been doing this crash course, which is based off on Leetcode and it's for data structures and algorithms. In the past videos, I've done the introduction for this course and also like the first topic, which is arrays and strings. And arrays and strings data structure has like quite a few patterns. So in the last part, I did like two-pointer approach with these two questions. So to get started, in this video, I'll be doing sliding window. And sliding window is essentially like two pointers, but works with the same, like it's just a little like you have to slide the window in terms of like right or left, depending on how you are solving and which problem you're solving. Um, yeah, for this one, mostly there is like focus on the arrays and then okay. And this concept of subarray, so any subarray is like continuous section of the array, and we can break it down into multiple elements. Like it could be just of length 1 or length 2 or 3 or 4 and so on. So that is a subarray, and it will have like a start and an end. And what is a valid subarray? So it should be like a the problem will explicitly mention for the valid subarrays, and there will be like a constraint metric, for example the sum of the subarray, or like find the number of unique elements in that subarray. So if that is the case, that is when we use this sliding window. And the idea is, as I was mentioning, to analyze and find the valid subarrays, and again like maintain two variable left and right at any given time, and then left will represent the left bound of the window and the right will be the right bound of that particular window. Yeah, and here we set it like at 0, which is pretty much like two pointers, but in this one left will only move when the condition is a particular condition is broken, that is the window size is broken. And this is just an example of like add elements on the right and remove from the left. So window slowly slides along this input. And yeah, and to see, this is just an example solving problems with sliding window. Again, as mentioned earlier, like find the best valid subarray or the longest valid subarray, or some constraint should be given for this particular pattern. And actually, I forgot to set my timer. Let me do 25 minutes. Yep. And implementation, we can just go over the pseudocode. It's just in the text above that explains it. So we initialize the first at like left and the current, and then we have like a sum answer, and then we go until like the right pointer is not out of bounds, which is like the max length of the array. And then we just increase the right, keep increasing the right pointer, and we add, like if we add it to the current sum, that particular number that we are the right pointer is at, and then if at any point the current sum becomes like bigger than k, then we just remove the sum's leftmost number like in that window, and then increase the left to 1 and find the answer. So this is like, I think, find the maximum sum of a particular subarray. Yep. And this is just a pseudocode. This is efficient because of the partial sum of the series. And in terms of time complexity, any algorithm like if you use will be like n squared, because you'll have to like take one subarray and then go and check the second subarray. So it will always be slow, but then a sliding window guarantees a maximum of like 2 n window iterations. So because like right pointer can only move n times and the left pointer can move n times. So it's like if logic done on each window is O of 1, then this will be a O of n algorithm as compared to n square. And yeah, since there are two loops, it could be like somebody could think why is it not n square? But like we are only sliding the whole array once. That's why. So in this example, given an array of positive integers number and an integer k, find the length of the longest subarray whose sum is less than or equal to k. That's what we were talking about, but this is how we are going to solve it. So in this one, we initialize at like left and current, so it starts at 3, both of them. Then the right pointer will go, and then in the current sum, we'll add like 3. So right now the sum is 3, which the condition like is smaller than k, so we move on. Then we add 1, then we add that's 4 to 6, and if we add this 6 plus 7, that will like make it a little too big. So then this is our current maximum sum so far. So we'll put that in the answer and then subtract this left here and from the current this number and then move our left pointer to this and then we'll again check like 1 plus 2 plus how long till it goes and what will be the maximum sum. So that's it. Even in this example, if you're given a binary string, you may choose up to 1, 0 and flip it to a 1. So basically, if we're given a binary string, we can, what is the length? We have to find the length of the longest subarray that contains only 1. So for example, if there is 0 here, then we can at most flip once and then count how many continuous like subarrays are there in the substring. So for this one, it's pretty much the same again. So if there is, we'll do like left current and answer. The current is the number of zeros in that window. So if anytime the current is bigger than 1, then we'll remove that left 0 and then decrease the current. And then if the right, like once you're looking at the subarray, anytime it conquers like at 0, then we increase the current by 1. Yeah, and this is the other problem where number of subarrays. So if a problem asks for like number of subarrays that fit some constraint, we can still use sliding window, but we need to do a neat math trick to calculate the number of subarrays. So what they're saying is like, let's say if this is the numbers and we have to find 8. So eventually like there could be 1, 1, 1 and then all of that. So what will happen is we'll have to do a right minus left approach because that will give us the window size. Yeah. So here what's going on is like if k is less than 1, then we're just anyway gonna return like 0. And then because we have to find like if we keep on multiplying the numbers in the current array, that is like 10 into 5 into 2 into 6 or 10 into 1 or 5 into 1, which is less than 100. So we will add that. So answer and left is 0 and current is 1. Current would be 1 here because we do not want to multiply anything by 0. And then we go over the entire right like array and then we keep multiplying the number that we are currently at by the current we have accumulated. And this is the breaking condition that if at any point there is current which is greater than or equal to k, then divide it from the left number and increase. An answer would be like plus equals right minus left plus 1. This right minus left plus 1 helps with like because it gets the window size and we want to add the window size, like how many elements in that window fit that particular criteria, and that is how many subarrays could be formed. And then if you find like the fixed window size, like it could not be a variable one. So given an array numbers and an integer k, find the sum of the subarray with the largest sum whose length is k. So we just do like add like the first k numbers and the current sum, and then we'll go and do like answer is that, and then for the range we'll start with k to end of the numbers, and then we can check all the conditions. So yeah, this is like the brief of how this algorithm works. Let's get started with this maximum average subarray one question. I think I've solved it before, but let me just refresh and description. Okay, so also like it's not that common, but still like this is the first part I think of many more before more complexities are introduced. So if we are given an array integer number, it has an element and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return the value. Okay. So basically, what's going on is like if we have k is equal to 4, so these are the possibilities, right? So there are four elements, whatever the average is, that is then that. Then there is these four elements, and that's it, like nothing else. So we have to find the maximum in that range. So we see that like if we do 12, these four elements would give the maximum subarray. So this would be like a good starting point. It's like a fixed window size as well. So what we're gonna do, like I mean in the interview setting, you're gonna ask like bunch of questions and right now come up with like your own examples as well. But since we're just like learning this pattern, I'm not gonna like focus that much on that. Okay. So what we are gonna do is we are gonna have a current and we're gonna have a left pointer. So I mean at current we can say that we would sum all the numbers in nums up until the k element, right? So that will do like 1, 2, 3, 4 till here. And then we find like max average, which is basically the current sum that we have. And then we go and go over for all the right in range. We start from k to len of nums. And then we're gonna find like max average, which will be max of current that we have, that is max average and like current. And how we find the current is when we'll have to add it, right? The current number that we are at to and subtract the window from it, like so that we do not exceed the current window. So which would be right minus k. Because the next element would be k distance away. And to return, we'll just go ahead and return the max average. Right now, I just like did not do the average just because like why add more complexity when at the end we could just do k, and anyway like whichever has the highest sum would have the highest average. So that should be the solution. Yep. And like if I do a quick dry run of what's going on here, so if you go to description, this is nums, right? Let's do that dry run here. Okay. So our current is sum of the first four elements. So that is 12 plus 1, 13, minus 5, 8, minus 6, 2. So current is 2. And then our right pointer would start here. Okay, till the end of the array. And this is our right pointer, and then our current is that. And okay, let's move forward. And our max average is equal to current, which is 2. Alright, once we move our right pointer here, so that is I think minus 6. Okay, current is nums plus equals number at right. Actually, hold on, I'm a little confused what's going on. Gemini. So here our right would be at 4 because that is where we ended it. And then when we go to 5, so the current would be at 5, current is equal to 51 plus 3 minus 12. I'll have to look into it, but I'm gonna stop this here. I wish I could do a better dry run. Maybe for the next problem, I should be able to do it. And I think I'm a little out of time, so I'm gonna stop this video here. Thanks for watching.